Hi guys, welcome to Metals Lesson 5. Today we are going to be looking at chemical cells and voltage. So our learning intention for today is to describe how metals and non-metals can be used to make chemical cells. And at the end of the lesson you should be able to explain why different pairs of metals will produce different voltages. So let's set a couple of things straight first. If we connect different metals together with an electrolyte to form a cell, we can produce electricity. And the purpose of using an electrolyte is to complete the circuit. The voltage between different pairs of metals varies, and that is what leads to the electrochemical series. Electricity can be produced in a cell by connecting two different metals in solutions of their metal ions. Let's look at this in a bit more detail. So we can use two metals to make a cell. When two metals are connected by an ionic solution, an electrolyte, a current will flow. So this here is an example of a chemical cell. We have salt water, which is our electrolyte, and we have copper and zinc connected by a voltmeter. Now electrons are going to flow from the metal highest in the series to the metal lower down on the series. The electrons flow up through So electrons are going to flow from the metal higher in the electrochemical series to the metal lower down. In this case, electrons are going to flow from zinc to copper, and they flow up and over the meter and down into copper. The further apart the metals are in the series, the higher the voltage produced. Say that again. Electrons will flow from the metal higher in the series to the metal lower down. In this case, they're going to flow from zinc to copper, and they will flow up and over through the voltmeter from zinc to copper. The further apart the metals are in the series, the higher the voltage produced. Now, very important to remember is that the electrolyte is needed to complete the circuit and is always a solution containing ions. If it does not contain ions, it cannot be described as an electrolyte and it will not complete the circuit. Okay, so if we were in class, we would give you the opportunity to use two metals to make a cell. So you would have copper metal and you would make a cell with copper and multiple other metals. You would connect copper to the voltmeter, you would layer some filter paper soaked in ionic solution between copper and the other metal you were using, and you would record the reading on the voltmeter. So some of the metals that we would let you guys use are things like zinc, silver, magnesium. You would test them one by one. You would then record the reading on the voltmeter. So here is our results table. Now, metal A could be magnesium, aluminium, zinc, lead, silver and gold. We would connect them in a cell with copper and we would get the following readings. As you can see, the further apart from each other they are, the higher the reading on the voltmeter. So magnesium is furthest away, it has 1.612, and lead is the closest, it has 0.52. Now because silver and gold are below copper on the electrochemical series, they have a negative reading. So, different pairs of metals give different voltages. If we were to list the metals in order of voltage reading, starting with the highest, this would give you the electrochemical series. It has the exact same order as the reactivity series we have been using in previous lessons. In a cell, electrons flow from a metal high in the series to one lower in the series. The further apart the metals are, the higher the voltage produced. So what we should have seen from the results table before is that the list of metals in order of voltage should be magnesium, aluminium, zinc, lead, copper between lead and silver, followed by gold. So here is an example of one of the questions you may be asked in a test or an exam related to this material. So you're shown the apparatus of two metals, X and Y, connected to a voltmeter, and they are in an electrolyte, a sodium chloride solution. Which of the following pairs of metals would give the highest reading on the voltmeter? So what we're going to do first is we are going to call back into our heads our electrochemical series. So I've now written out the order of metals on the electrochemical series at the right hand side. Now remember, the highest reading will be the pair that are furthest apart on the series. So let's start with A, iron and zinc. They are right next to each other, so they are unlikely to produce the greatest reading. Magnesium is here and silver is down here. So they are pretty far apart, and it looks like that probably is going to be our answer. But let's rule the others out first. So we've got zinc, copper, two metals between them, not as big a gap as magnesium and silver. Zinc and silver, zinc, silver, a big gap, but since magnesium is higher than zinc, magnesium and silver are further apart. So the answer to this question will be B. Another question. Which pair of metals, when connected in a cell, would give the highest voltage and flow the electrons from X to Y? So it's the same style of question as last time. In an exam or any kind of assessment, you are going to have your data booklet which has your electrochemical series included. That means that this is going to be the high metal and this is going to be the low metal. So that means this is going to be So what that means is metal X is going to be higher in the electrochemical series than metal Y. So zinc and tin. Zinc, tin, only one metal separating them out. Copper here, magnesium all the way up here, they are the furthest apart. So bearing in mind that magnesium and copper are the furthest apart, that leaves us with C and D. Now I've also said that the metal higher has got to be on the left hand side and the lower on the right. So metal X then must be magnesium and metal Y must be copper. Our answer is D. The next thing that we are going to look at are metal half cells. And the example we've got here is the half cell made from zinc and copper. So in half cells, metal electrodes are placed in solutions of their own ions. So down here we have zinc metal electrode in a solution of zinc sulfate. So zinc ions are present here. And here we have a copper electrode in copper sulfate, this blue solution containing copper ions. Now, as in the cells we were looking at before, electrons are going to flow from the metal higher to the metal lower in the electrochemical series. In this case, they're going to flow from zinc to copper, and you can see that earmarked by the red arrows. Now, where before our electrolyte completed the circuit, in this case, in the case of half cells, we have what's called an ion bridge, and that is filter paper soaked in sodium chloride solution, it's soaked in salt solution. And that ion bridge will complete your circuit. Common question that can come up in exams is what is the purpose of the ion bridge, and you just have to say it completes the circuit, or it'll ask you to complete the half cell diagram, and often it'll have left out your ion bridge. Okay, so let's consider this in slightly more detail. So electrons are flowing from the metal higher to the metal lower. So let's think about what's happening at the zinc electrode then. So this zinc metal is going to be losing electrons. So I'm just going to jump up here and remind us of oil rig. Oxidation is loss of electrons and reduction is the gain of electrons. So zinc here is going to be losing electrons as they are flowing away from the metal, so flow from the metal higher to the metal lower down. So that means that zinc is going to be oxidised and copper over here will be gaining electrons. Now, so zinc is losing electrons. They are flowing through this wire, through the voltmeter and into the copper electrode. Now, the electrons continue to pass through the copper metal and into the solution, where they meet copper 2 plus ions. Now, these copper 2 plus ions accept the electrons from the zinc to form copper atoms. So the ions, which are in solution, form solid copper on top of the electrode. So, will the zinc electrode increase or decrease in mass? Well, what's happening is zinc is becoming zinc ions, so it will decrease in mass. The copper electrode, that is gaining electrons, so electrons are flowing into the copper electrode, and we've seen that copper ions in solution were gaining electrons to form copper atoms. Therefore, the copper electrode will increase in mass. Now, copper sulfate is a blue solution, and it is blue because the copper ion is blue in colour. As more of these copper ions are reduced to solid copper, the colour will change from blue to colourless. So this slide here just summarises the ion-electron equations for the reaction that we've talked about. As I've said, zinc is oxidised to zinc ions and copper ions are reduced to form copper atoms. If we combine the oxidation and reduction equations, we can get our redox equation, which looks like this. And it is zinc solid plus copper 2 plus ions in solution, giving zinc 2 plus ions in solution and copper atoms. So here is an exam style question on half cells. So the diagram shows a simple battery made from copper and zinc discs separated by paper soaked in potassium nitrate solution. The purpose of potassium nitrate solution is to complete the circuit. State the term used to describe an ionic compound which is used for this purpose. Now, an ionic compound used to complete the circuit would be called an electrolyte. A student has set up a cell using the same metals as those used in the battery, copper and zinc. Copper is in a copper nitrate solution and zinc is in a zinc nitrate solution. So on the diagram, draw an arrow to show the path and direction of electron flow. So remember, that electrons will flow to the metal higher on the electrochemical series to the metal lower. And in this case, zinc is the metal higher on your series, so electrons will flow up and over to the copper electrode. Name the piece of apparatus labelled X. It is your ion bridge. So that brings us on to cells involving non-metals. Now, electricity can be produced in a cell when at least one of the half cells involved does not involve metal atoms. The electrodes can be a conducting non-metal, for example, carbon in the form of graphite, so we would use graphite electrodes. And we would also have an iron bridge, again, to allow the movement of ions to complete the circuit. The ion bridge is soaked in an electrolyte. So what we have here is we have what we have here is an example of such a cell. Here we have a carbon electrode in potassium iodide solution and a carbon electrode in iron 3 chloride solution. Now, if we were to consult our electrochemical series, we can see that iodide ions are higher in the electrochemical series than iron 3 plus ions. So, if we have iron 3 plus, which is lower than iodide ions, electrons will flow from this beaker to our iron beaker. Our iron ions will be reduced to form iron 2 plus ions, and our iodide ions will be oxidised to form iodine. So a quick question on non-metal cells. So electricity can also be produced in a cell containing non-metals. And the reactions occurring at each electrode are beaker A, which is here, liquid bromine Br2 plus 2 electrons gives 2 Br minus. Beaker B, SO3 2 minus plus water gives SO4 2 minus plus 2H plus ions plus 2 electrons. Name the type of chemical reaction taking place in beaker B. So what we have to remember again is oil rig. Oxidation is loss of electrons, reduction is gain. So let's look at beaker B. In this case, the electrons are on the right hand side of our equation. Our rule for the placement of electrons is that if electrons are on the left of the arrow, it is a reduction, and if they are on the right of the arrow, it is an oxidation. So the type of chemical reaction occurring in beaker B will be an oxidation reaction. You are then asked to write the redox equation for the overall reaction. In order to write a redox reaction, you have to eliminate or cancel out the electrons on each side of your arrow. They already cancel out. We've got 2 and 2. So our overall redox equation then would be, and I'm going to write it up here because I've not got a lot of room down here. It would be Br2 plus SO3 2 minus plus H2O gives 2 Br minus plus SO4 2 minus plus 2H plus. So to summarise then, an electrolyte completes the circuit and it must be a soluble ionic compound. Electrolysis is splitting compounds up using electricity. We talked about that in our extraction of metals lesson. The compound must be a liquid or in solution to be electrolysed so that the ions are free to move towards oppositely charged electrodes. Carbon electrodes are used as they are unreactive. During electrolysis, both oxidation and reduction take place. Now, on to the things that we've discussed today. In a simple chemical cell, two different metals are placed in a solution called an electrolyte. In a cell that has two half cells, metal electrodes are placed into solutions containing their own ions. In a chemical cell, electrons flow up and over from the metal higher in the chemical series to the metal lower in the electrochemical series. Now, the further apart the metals are in the series, the larger the voltage produced. And for chemical cells involving non-metals, carbon electrodes are used as they are unreactive. So that takes us to the end of today's lesson. If you have any questions, please fire me off an email and I'll get back to you as soon as I can. Thanks for tuning in, and I will see you all in the next one. Bye guys.